Hi everyone. So this weekend I just started exploring a little bit this framework called Mongoose. So Mongoose is a web server framework for embedded systems. So essentially think about what you would do with Node.js to serve an API or host or serve a web page or an app. You can do the same from a microcontroller now and not just a computer. So things like our little handy dandy esp32 can do that. Now, one thing to keep in mind is that esp32 has been doing that for a long time. They have their file system in there where you can upload from the Arduino IDE HTML files, and the esp32's web server stack, the APIs can actually already do that. But Mongoose looks very promising. You can have nice dashboards, and you can have extra features like logins and dashboard logins and security and HTTPS and all that stuff. And essentially it does the same things, right? It can detect sensor data, post it, and you can see it on that served HTML, or vice versa. You can have switches, toggles, and you can turn things on and off and things like this. So now the question begs, like, okay, there are things like Home Assistant and Tasmota, which I've been using for all my smart home stacks, and all the ESP32 has been flashed with that, or ESP8266 has been flashed with that. What's the benefit of this? Like, I mean, look at their clientele, and they seem to be like very promising in that regards, that it's suited for much more better integrated solution for more where I would say it's a little bit beyond hobbyist, but good for serious development and serious environments where you might want to have, let's just say, like you're building a switch or something, or a button within a car, and you have this framework where you might want to change the MQTT protocol topics and things like that, but you don't want anyone to just like get into it, or you don't want things to be accessed over serial to flash the microcontroller once it's deployed. These web services could be handy, where you can have a secure login, and then only you can do such thing. So of course this is also available in Tasmota and things like this, but it just looks a little bit more nicer, I think. And they have these web UI builder and things like this. I have been exploring that, but it's very I wouldn't say it's there yet. The boilerplate codes that they generate are pretty buggy. I have been posting it on their Discord channel, so if you're interested, have a look. But I thought of let's take a step back and start with the basic. Like, what would a simple Node.js server, once you start writing Express, what do you do? You learn about endpoints, and if you hit that endpoint, after it starts serving over a certain port, you get some result as JSON or a text and things like that. So this is exactly that example exists in their Git repo. So I started to actually just experiment with that, but I wanted to do it in PlatformIO and not from Arduino IDE. So there were little gotchas. The beautiful thing is that Mongoose doesn't come as these dynamic libraries that only resides in these environment-specific library repositories. So for example, Arduino has the Arduino library repository. What Mongoose does is just essentially it's agnostic of such things. So it literally has these two files called, as you can see, mongoose.c and mongoose.h, and if you go into every single example, you'll find this. So it's not coming from a central place, it's actually within the project itself. So that's kind of cool. So to port that in PlatformIO, we couldn't simply have the library dependencies mentioned here in the ini file of PlatformIO. So what I had to do is we actually had to put these two header files within the lib directory of the PlatformIO file structure of our project, and these two, let's just say the header file and the C file, and the config file is where we define the architecture of the target microcontroller that we are using. But this two main file remains in here, I would say, and then in the ini file we give it, like during compilation, how to look and where to look for all the includes within our main source code. You can see in the VS Code it's still not able to find it, but it compiles, which is very weird. I've been struggling with that for a while to get rid of it. I checked in the VS Code properties, it's also, I would say, there. Like you can see the includes are there. The lib is not there right now, but that shouldn't be an issue. I have adopted the code quite a bit, just some best practices. Like you can see here in the Arduino code in their Git repository, they have just like, hard-coded the credentials. I essentially said like, let's move it to a file called credentials, which we have put into our include directory of the PlatformIO, and I have left essentially an example file on how to actually write that. And so the main credentials.h will be ignored by the git ignore, but during compilation it's actually included here with the credentials.h. But the main cool thing here is that the code is pretty small. It might look very daunting first, but let me walk you through very simply what's happening here. We have a Mongoose object that we are instantiating. We'll point towards it later on in a bit. But the cool thing here is like this event handler. Just like in Node.js, we have asynchronous event handling. This is not asynchronous per se, but esp32s have multiple cores and things like that, so you can run things asynchronously. And here it just essentially it's happening during the polling. But what's happening in the event handler is very simple to understand. Just like if you have done Node.js or Express, have written APIs or have served endpoints and managed what to serve when, this would be very, very easy. So we are doing essentially three things here. We are saying like, hey, once the server is started and if the server receives this endpoint, then just toggle the LED, turn the LED on, and send a JSON saying like the LED status is on. If it's off, if you receive an endpoint with off, then turn the LED off and send a response back with the LED status as off in the JSON format. And also if we receive anything else, then just send a JSON response of the flash memory data. And that's all it's doing. Rest of the code is just about the basic stuff. Start the serial, wait for the serial, set the LED pin, instantiate that, or wait, this is a pointer to the Mongoose class, and then we're setting some log level so it can print out essentially the server outputs, the server debug messages. And here we are just instantiating the Wi-Fi stack, connect to the access point of our SSID, get the IP address, print it here, and then finally start the server running. And here you can define, of course, when we go down writing the code a little bit more better, we can separate these things. We can actually define them in the macros already, the ports and all that stuff. And that's all it's doing. The code is flashed. Let me just refresh and reset the Pi, so you can see that it's now trying to connect. It's connected to the Wi-Fi. It has gotten the IP address. We're all good to go, and now the server is running. So how do we know the server is running? Let's actually open up. Let's go here. This is our IP address, right? So if we take this IP address, HTTP, and if we just do 8080, we will get a JSON response back, and that it's saying like this is our free RAM space remaining. So you can see here in the debug messages the server outputs as well. We can actually just stay on this screen and do a curl and then see those things. So if we do LED on, let's see if we see the LED on turning on. We received LED is on as a response back from our server, and then our LED is, that red LED is on. If we do LED off, we will see our LED should be off. Why isn't it off? Weird. It is off. I think my camera froze. Oh yeah, now you can see it's off. And then on again. And then if we do something else, anything else, we will get a response with the thing. So this is the step one in understanding how Mongoose works for me. So essentially, again, this is the routing that's happening here. And the next example, we'll do the same thing, but essentially the server will be serving an HTML page, and then there'll be a toggle button, and it'll do the same thing where it'll hit the endpoints and get the same sort of responses and things like this. So, and then in the next example, I would say I would try their web wizard because it's still buggy. Again, as I said, I have posted in their Discord channel. Let's see if they fix all this stuff. So I have to also study that a little bit. But this is step number one, using Mongoose.